Professor Madhumita Goswami Madam, Associate Dean HBNI, distinguished faculty members, scientists, researchers, students, and all the participants. A very warm welcome to everyone present here on the occasion of National Science Day 2026, organized by HBNI. As you all are aware of this fact that National Science Day is celebrated every year to commemorate the discovery of Raman effect by Sir C.V. Raman and to reaffirm our commitment to scientific temper, research, and innovation for national development. We are privileged today to have with us Professor R.V. Grover sir, who will be delivering a lecture on the topic Rationale Behind the Shanti Act. To begin the program, I request Professor A.K. Tyagi sir to kindly deliver the welcome address, please.
Thanks, Shri Sahu. Respected Professor R.B. Grover, Founding Director of HBNI, my colleagues, Shri Sahu, Registrar HBNI, my colleagues from HBNI, BARC, and I see number of people have joined online also from our different CIs and OCC. And likewise, there are participants who have joined YouTube. Let me welcome all of you who are present offline with us and online. Today we have assembled to listen to a remarkable personality produced by DAE. And this personality is Dr. R.B. Grover. Of course, he will be formally introduced by my colleague Dr. Goswami. He has rich experience of about 55 years in DAE, and he has been instrumental at various crucial stages of DAE to sail through. You will know more, of course, when he is formally introduced. When we were discussing about the chief guest for this occasion, unanimously we thought that in today's world, when everyone is talking about Shanti Act, no one can be better than Professor Grover. When we approached him, very graciously, he agreed. He gave his consent, maybe within 1 hour or so. So we are grateful to you for kindly sparing your time and being with us. Just a preamble of this lecture. You all know Dr. Bhabha was pursuing a career in Cavendish Lab, UK. He came to Mumbai in 1939 summer to spend some time with his parents, and it so happened destiny had different plan for him. On 1st September 1939, World War II started, and he could not go back. He joined TIFR in same year, and he was there for, he joined ISC Bangalore, and he was there for several years. It was June 1st, 1945, when he set up TIFR. First for 6 months from ISC Bangalore campus, and then of course it moved to Mumbai, and TIFR got its present location. That also was in early 1960s. After India got independence, Dr. Bhabha started intense efforts to initiate atomic energy program. It was due to his efforts that within a year of getting independence, on 10th of August 1948, Atomic Energy Act was passed. This is first Atomic Energy Act, 1948. Subsequently, you all know, on 3rd January 1954, AEET was established, present BARC, Atomic Energy Establishment Trombay it was called. It was renamed as BARC after Dr. Bhabha's untimely death in January 1966. On 3rd of August 1954, DAE was constituted, and Act was amended in a major way in 1962 also. It is called as Atomic Energy Act 1962. Then, of course, we are at the cusp of a new type of history, which we are fortunate to witness during our lifetime. Recently, Government of India moved Shanti Bill. It was deliberated for long time. It was passed in both the houses, and Shanti Bill became Shanti Act. This is the right time for all of us to learn what this act entails about. What are the benefits? What are the pros? Are there any cons? All those things I am sure you all would like to know. And this talk will be on YouTube forever. So I'm sure it is going to help a large number of people to know from the person who was directly associated with all this major exercise. Let me once again welcome Sir you and welcome to you all also. Thank you very much.
Thank you, sir. May I now invite Professor Madhumita Goswami to kindly introduce the distinguished Professor Grover, sir.
Thank you, Sav sir, and very good afternoon to you all. It's a privilege and honor for me to introduce Padma Shri Dr. Ravi Bhushan Grover for today's function. Dr. Grover, born on 17 February 1949 in Punjab, he graduated from Delhi College of Engineering in Mechanical Engineering and joined BRC in the year 1971 after graduating from 14th batch OCS BRC Training School. He was awarded PhD degree from Indian Institute of Science in Mechanical Engineering in the year 1982. Dr. Ravi B. Grover is a renowned nuclear scientist and academic leader, best known as founding director and former vice chancellor of Homi Bhabha National Institute. Currently, he is a member of Atomic Energy Commission of India, chairman Board of Research in Nuclear Science, and distinguished Professor Emeritus HBNI. Dr. Grover has been widely honored for his contribution to India's nuclear program and academic leadership. On 15 January 2013, the Prime Minister of India conferred on him the Lifetime Achievement Award for the year 2011 for his outstanding contribution in the field of nuclear energy, international civil nuclear trade, and human research development. Subsequently, in the year 2014, he was awarded the Padma Shri, one of the India's highest civilian honor, in recognition of his pivotal role in advancing nuclear science and policy. Apart from this, he is a fellow of Indian National Academy of Engineering and the World Academy of Art and Science, reflecting his global standing in the scientific community. Delhi College of Engineering Alumni Association bestowed him with a Lifetime Achievement Award in the year 2016 and distinct 2009. Moreover, he was awarded Dhirubhai Ambani Oration Award by Indian Institute of Chemical Engineering in 2008 and Distinguished Alumnus Award by Indian Institute of Science Alumni Association in 2011. The list of his award will be non-ending. So with this, I now request Mr. Sahu to continue the program further. Thank you.
Thank you, madam. May I now invite Professor R.B. Grover, sir, to deliver his lecture on rationale behind the Shanti Act. Sir.
mic. दूसरी थी वो भी निकाल देना मैंने एक दिया दूसरा ओके के पास होता है Yes. Good afternoon to all. Dr. Tyagi, Dr. Madhumita Goswami, Mr. Sahu, and colleagues from BARC, HBNI, HIDD, and students and faculty who are joined online. This is a topic, Kranti Act, which has been in the news now, I think, a whole of 2025 and in 2026 also. There's a lot which is being talked about this bill. How it came about, what happened, why government pushed for it, that is what will be my attempt to tell you some details during this next 45 to 50 minutes. One thing which perhaps many of you know, that Human Development Index directly correlates with final energy consumption, per capita per annum final energy consumption. I think here one should remember that primary energy supply is another word we use, electrical energy is word we use, but here we are trying to say final energy consumption. In early days, people were using primary energy supply or electrical energy, but in recent years, energy economists have shifted to the use of the term final energy consumption. The reason being that when we see total energy supply, we have coal, we have nuclear, we have hydro, and we have solar and wind. Solar and wind directly give you energy, while coal gives you certain kilocalories in terms of its calorific value, and that has to be translated to electricity, and there's a thermodynamic efficiency of 33%, 34% involved. So summing up all these and the different energy sources became very difficult. So energy economists have now changed over to the terminology total final energy consumption. So it is a sum of consumption in the end use sectors and includes non-energy use. What is this non-energy use? We use energy derived from coal or petroleum. We use carbon molecules also as reducing agent in industry. Particularly in blast furnace, we use carbon molecules to convert iron ore to steel. Similarly, for making ammonia, we use hydrogen, which is formed by steam methane reforming or for natural gas. So this and the non-energy use of these molecules is also included in the term final energy consumption. So here I have a plot where x-axis is final energy consumption. No, it's what is this? Okay, I think while okay, it has come back. Fine, I'll just explain here only. So x-axis is this is not going.
Yes, the screen.
This is, but I was trying this pointer.
Pointer
अलग है
different.
Okay, okay, ठीक.
Sliding thing.
So here x-axis is final energy consumption per capita in gigajoules per capita per year, and here we have HDI. If you see this, the way final energy consumption increases, HDI increases. So blue dot are those countries where HDI is below 0.9, and red dot for those countries where HDI is higher. India is here, this green dot, 19.3 gigajoules with HDI of 0.645. This is 2019 data. Note one thing, that no country, but we'll come to this point later, this is an outlier. No country has been able to have a high HDI that is above 0.9 unless they have per capita energy consumption of more than 75. Okay. So if India wants to have a HDI of 0.9, this is a kind of energy which has to be consumed. This outlier is for Hong Kong. Hong Kong is a city-state, no agriculture. They derive all their income from being a financial capital. So that cannot be the model for us. India is a country where we have to have manufacturing, agriculture, service, everything has to be there. So we have to look at other countries. That means our energy consumption has to be something like 75 gigajoules. And if we want that kind of per capita consumption, our total energy will be something like 31,000 or 32,000 kilowatt hour. I'm using the units for electrical energy, but I denote with that the total energy here. So we developed for this purpose different scenarios and came up that we will need for various scenarios. We found that one gets 15,500 to 18,000 is the kind of per capita energy we need, and we selected a benchmark 16,000. This benchmark was selected just to go with a one number rather than going with a range of numbers. You multiply this by population of India and all that. The total energy which we found India has to generate to have a SDI of 0.9 is something like 24,000 terawatt hour. A part of it will be used as electricity, and a part will be used to generate hydrogen. In the electrolyzers, one will generate hydrogen, which will be used in hard-to-abate sectors like production of fertilizers, production of ammonia, and so on and so forth. This hydrogen generation, there may be in future some other techniques. To that extent, 24,000 will come down. So I think here, before proceeding further, let us have some data. So to reach HDI of 0.9, generation has to increase from 2250, which is the generation now. This is a rough value. The final data will come very soon, published, to 24,000. That is 10.5 times. But if we see electrical energy is roughly 22% of the total. So electrical energy, total energy has to increase 3 times, electrical from 2250 to 24,000. So this is the kind of journey which we have to see. And this compounded annual growth rate in last 10 years, which has been reported in this publication, Energy Statistics 2025, was about 4.8%. And if we continue to grow at this rate, we will be able to reach this 24,000 in 2060, 2050, around that time. So that being the scenario, but it's not that we have to grow at 4.5% or so. We also have to transition to a net zero system. We cannot be growing in business as usual manner. We have to substitute fossil fuel with clean energy sources. So net zero would require a massive shift to electrification of are forecasting less than 24,000, but they aim SDI of 0.8. SDI of 0.9, then it is 24,000. If you see here in the previous thing, to move from 0.8 to 0.9, this curve is asymptotically changing here. Character is changing. Massive energy change is required. By the way, this sort of result paper which is referred here is a part of a HBNI PhD students who is in BRC. It's our work only, and it was quoted by the chief economic advisor in the what is known that in the economic survey presented to Parliament in the month of July. So we have to, what we looking at this, that if we have to grow on the basis of solar, wind, nuclear, and hydro, so how much can we get from solar and wind and hydro? So there are various estimates. The earliest estimates which I could get in the literature is a paper published in 2012 by Professor Sukhatme of IIT Bombay. He gave a range. This can be the range which we can get from these sources. We estimated our own based on, again, work by a PhD student here in HBNI. We came out number is something like 5,500 terawatt hour. So our requirement is 24,000. Solar, wind, and hydro can give us only 5,500. Where do we get the rest? We'll get the rest from nuclear. At the same time, both academic studies and field experience indicate that system cost increases as the penetration of intermediate sources in the grid rises. Solar and wind are intermittent sources. So grid has to be balanced. Supply and demand has to be always equal. So when wind and solar are not available, then either we have to store whenever they are available, or we have to go in for power cut. We will not be able to provide energy. So this aspect, as the penetration of intermittent sources is increasing, this was a fact which was not realized by political class, and under pressure of green rhetoric, professionals were remaining silent. But how long one can remain silent? Finally, the fact has come out, and result is in the economic survey presented only in the month of January this year. This is what Chief Economic Advisor writes. The real cost of renewable power at scale includes storage, reserve capacity, balancing operations, and transmission reinforcement. This cost of all these things become very high. This is acknowledged in the, rather he devotes 3 or 4 pages in chapter 10 on this aspect of solar and wind. So result is the government announced a target of 100 gigawatt for nuclear to be achieved by mid-century. So if we have to achieve this target, that means we have to bring in more players into nuclear energy. So that's how the Shanti Act has come into being. So before I go to Shanti Act and what are the things which have been included in Shanti Act, let me first explain 3 important terms which we use in the nuclear industry. I think those who are from training school, they must have heard them in the training school, but might have forgotten, if not subsequently worked in these areas. These terms are safeguards, security, and safety. And one tends to translate all 3 of them to suraksha, but they have a very different meaning when we use in nuclear industry. Safeguards refer to nuclear material accounting. Nuclear material is a sensitive material. It has to be accounted for. And for this purpose of implementing safeguards, all sorts of issues like surveillance by video cameras, containment, all those things are used for this along with material accounting. Security is physical security. It is a physical protection of nuclear materials and facilities. I think this meaning is very clear, that we have to ensure that no one is able to sabotage any facility. And nuclear safety refers to achieving proper operating conditions, preventing accidents, and mitigating their consequences to protect workers, public, and environment from undue radiation risk. This is the meaning of the term nuclear safety. This is something when we think of safety, security, safeguard, of this aspect only. Safety and physical security of nuclear facilities and materials are very important. I think it's obvious, one doesn't have to sort of specify it in much more detail. But issues influencing increased exploitation of nuclear power are safeguards and export controls which resulted from safeguards. These are related issues. Though safeguards predate NPT, they arose from a nuclear non-proliferation treaty, and we'll see why that treaty came into being and what's happening as a result of that. The nuclear regime which has resulted during the last several decades, it's very complex. We have international treaties. NPT is the main treaty, and to maintain export controls, to ensure that sensitive technologies do not fall into wrong hands. We have United Nations resolutions which we have to comply with. We have guidelines of the International Atomic Energy Agency, which are both in the area of safeguards, in the area of safety, in the area of physical security, and they are very helpful in implementing the program. Then we have standards of ICRP, that is International Commission on Radiation Protection, and of course, informal understandings between various countries or various groups of countries. And India has been trying to derive benefits from nuclear science and technology for the welfare of the nation, right? As Dr. Tyagi said at the beginning, right from the time of independence, we have been working in this area. And the first act was enacted in 1948, which was recently the new act came in 1962, and now we are the 2025 act. But whatever we have done, we have honored our legal obligations and informal understandings. That we have been, our behavior, our outlook has been very, very responsible. So at the same time, we are following a science-based approach to regulation. And this is something responsible behavior and science-based approach has to continue as we expand the role of nuclear power. And this complexity of the nuclear regime that influences nuclear power because of intertwining of nuclear fuel cycle for generating electricity and nuclear weapon technologies. They are, for much of the way, they are same. And this does influence the growth of nuclear power. We have non-power applications of nuclear science and technology as well. They are in the area of healthcare, industry and agriculture and research. But they are not influenced by this regime. Regime is kind of benign towards them. We have maybe more than 700 nuclear medicine centers in the country, and all the details, numbers, if you want to have a look, you can look at the latest annual report of AERB. They provide all the details about extent of non-power applications. So I'll not be touching this in the rest of my lecture. How the nuclear regime has evolved. So let us see its evolution and early development. The very first event from which mankind came to know about nuclear energy was the Trinity test conducted by USA on 16 July 1945. And I think those of you who have watched the movie Oppenheimer must have seen how the whole thing came about. And subsequently, weapons were used on 6th and 9th August 1945 in Japan. Again, Second World War came to an end after that. Of course, Japan was about to end the war, but this became another factor. Considering the devastation which was caused, there were a lot of movement within the United States, and a report was commissioned which came out in 1946. This is known as the Acheson-Lilienthal report. Oppenheimer was a member of this committee. What this report says is that development of atomic energy for peaceful purposes and the development of atomic energy for bombs are in much of their course interchangeable and interdependent. Again, full intertwining, which I said a little while earlier. And they conclude that a system of inspection superimposed on an otherwise uncontrolled exploitation of atomic energy by national governments will not be adequate safeguard. So they are trying to say something more has to be done. And incidentally, this information is just as an add-on information to this lecture. UN Charter was finalized just a few weeks before Trinity tests. They do not mention nuclear weapons. I think such an important body which is meant for governance at the global level, there is no mention of nuclear energy in their charter. Next important event is a speech by President Eisenhower in 1953 to UN General Assembly, which is known by the name Atoms for Peace. They proposed IAEA, and this combines essentially sharing of knowledge but with surveillance. This is a speech which has been debated a lot. Academics still keep on writing about it. Some academics write that the purpose of this initiative was surveillance and control and not sharing. Some say otherwise. So I think there are different views in the literature. You can pick up those who are interested in this kind of historical research. You can read papers and papers on this issue. But what finally it has evolved into is a regime which I think one can call as control over the atom even when used for peace. This is where the regime is. Subsequently, 18 Nation Committee on Disarmament was sponsored by United Nations in 1961. It negotiated the Treaty on the Non-Proliferation of Nuclear Weapons, colloquially known as NPT. And by 1964, there were 5 nuclear weapon states. This treaty entered into force on 5th March 1970 and was extended. Initially, its duration was 25 years, but after 25 years elapsed in 1995, this treaty was extended indefinitely. Now, these dates are important in the context of the topic today. India enacted the Atomic Energy Act, which is currently in force in 1962, and all this happened after 1962. NPT coming into force and everything, indefinite extension in 95. This has all these developments are subsequently. The regime which has resulted from the treaty is that there are 5 recognized nuclear weapon states, and for the purpose of this treaty, a nuclear weapon state is the one which has manufactured and exploded a nuclear weapon or other nuclear explosive device before 1st January 1967. All other states are non-nuclear weapon states. They can pursue a nuclear program only under IAEA safeguards, and safeguards obligations by non-nuclear weapon states are met by signing comprehensive safeguards agreement. The word comprehensive is very important. It means safeguards apply to all activities pursued by them. That is why they are comprehensive. But those countries who have not signed NPT, for them, they are facility-specific safeguards. They were existing prior to NPT, but they are only facility-specific programs. That means only those facilities which receive an international cooperation, they are subjected to safeguards. The purpose of facility-specific safeguards is to prevent diversion from peaceful uses to nuclear weapons or other nuclear explosive devices. To implement NPT, how exactly we implement, what kind of controls you should have. United Nations set up a committee in 1971 under the chairmanship of Ambassador Zenger. Zenger's understanding established a list of material and equipment which have to be subject to export controls. Along with that, they had 3 conditions of supply. Number 1, non-exclusive use assurance that the recipient country will not use this for explosive developments. Non-exclusive use assurance. IAEA safeguards requirement. Number 2, IAEA safeguards requirement that all the received material will be subject to IAEA safeguard, that is complete control and surveillance by IAEA. And a retransfer provision that if the recipient country transfers this particular material forward, the receiving country will also adhere to these obligations of non-explosive use and IAEA safeguards. In 1975, a few countries came together and established Nuclear Suppliers Group. Initially, it was known as London's Club, and gradually evolved into Nuclear Suppliers Group. It adopted guidelines for international trade in nuclear technology. This Nuclear Suppliers Group was inactive up to about 1992. It was existing but inactive. But in 1992, it established a framework for dual-use items. That is, dual-use items are those items which can be used by nuclear industry as well as by other industries. There are several items which are common. Under Nuclear Suppliers Group, now there are 2 lists, Part 1, Part 2. Part 1 is known as trigger list, which is meant for only nuclear use, and Part 2 is a dual-use item, that is, which can be used for nuclear as well as for other industries. NSG, if you see here, in NPT, you have facility-specific safeguards for countries that are not a party to NPT. But NPT require application of full-scope safeguards as a condition for nuclear supplies. That is, they want no comprehensive safeguards. It goes beyond NPT. That means India is not a signatory to NPT, but because of this thing, full scope safeguards, we were not able to import uranium once these guidelines were enforced. So India and NPT, just if you see what is the relationship, India was a member of the 18-nation committee on disarmament, which drafted NPT and was taking very active part in the drafting process in the early years. But China detonated a device in 1964. It became a non-nuclear weapon state. India was forced by the geopolitical consideration to change its stance. At that time, maybe if you read the history of those years, India was looking for security guarantees. No country gave any security guarantee to India, and therefore India decided not to sign NPT. India has still not signed it, though there are calls even now that India should sign NPT, and India has been consistently refusing to sign NPT. And if you want to read history of those years, this is a book from faculty member of Cornell University, Jaita Sarkar, Plowshares and Swords, published in 2022, right from the beginning of the program till about 1972-73. This book gives a complete history. It's worth reading to those who are history buffs. Then India went in for Shakti series of tests in May 98, and the then Prime Minister Atal Bihari Vajpayee made a statement, India is now a nuclear weapon state. This is a reality that cannot be denied. Just see the confrontation with the NPT, this statement made in Indian Parliament. It's not a conferment that we seek, nor is a status for others to grant. It is an endowment to the nation by our scientists and engineers. At the same time, these pressures were continuing. This similar question was posed in November 2009 to the then Prime Minister Manmohan Singh. He said yes, India stated that India was prepared to join NPT as a sixth NWS. You see bipartisan support, both sides of the political spectrum making similar kind of statement. So now we can come to evolution of nuclear regime. NPT entered into force in 1970, 8 years after Atomic Energy Act 1962. Of course, there have been other treaties which you will find are considered very important. One is the Comprehensive Nuclear Test Ban Treaty. It was negotiated and signed, but it has not entered into force because countries are refusing signing. They are refusing to ratify it. There is a talk of fissile material cutoff treaty, and the talk has been going on for the last 3 decades, but that has never been drafted. There is no progress towards disarmament by those countries who have nuclear weapons. There are no checks, qualitative or quantitative, on vertical proliferation. Those who are having weapons, they are increasing numbers as well as the quality of weapons. But the instruments that are restrictive for non-nuclear weapon states, they are thriving. What are those instruments? Earlier it was safeguards agreement, and then came strengthened safeguard, that is additional protocol. Additional protocol, all NNWS are supposed to sign with IAEA. It essentially have provisions for environmental detection, that environmental sampling can be done in the country to detect whether any country has an undeclared nuclear weapons program. Then we have a nuclear suppliers group. They have export control. There are extensive reporting obligations for government. Guidelines of IAEA, standards of ICRP, of course, they are very helpful, but they are very much there. Then the way geopolitical situation at the global level was evolving, particularly the incident which happened in New York on Twin Towers, nuclear physical security became very important. President Obama gave a speech in Prague in 2009, and proposed a nuclear security summit process so that physical security regime can be strengthened. And 4 summits were held in 2010, 12, 14, and as a result of that process, there is a Convention on Physical Protection of Nuclear Materials and 2005 amendment. Many countries were not party to it. Now most countries of the world have signed it and ratified this convention. This was an important step to bring home the fact that physical security is very important. So where do we stand today? India conducted nuclear tests in 98. And intense diplomatic activity followed to ensure growing acceptance of India as a responsible nuclear power. These efforts led to NSG revising its guideline in 2008 to facilitate international civil nuclear trade with India. Starting from 98, it took 1 decade to reverse what we wanted to achieve. And this was a reversal of 95 decision of NSG, which said that NNWS have to go in for comprehensive safeguards or full scope safeguards. It came back to facility specific safeguards. So this particular change removed a major constraint for the expansion of nuclear power program. In parallel, NPCIL has been working on PSWR technology. They have been increasing the size of the reactor which they're constructing, and now they have a 700 megawatt PSWR. And that supply chain in India, this also has now a mature design with the help of which we can proceed forward. So we have overcome uranium availability constraint and met the challenge of developing indigenous technology. India is now ready for an ambitious nuclear power program. In 2000, situation was so bad that our power reactors were working at capacity factors as low as 50% since uranium was not available. Now, after that scenario has changed, we are not only constructing more reactors, our reactors are operating also at very high capacity factors. So what are the implications of safety, security, and safeguards? As far as the safety and security is concerned, as I said earlier, there are no issues. They are helpful with the implementation of safety measures. Plant safety and plant capacity factors have improved. These plants have become more profitable. Security is necessary due to the prevailing geopolitical scenario, not only in India, but similar things are there all along the globe. But security compliance with safeguards is definitely burdensome. Why safeguards? Here one needs to recall the fundamentals of physics, the fission reaction, and the concept of critical mass. By appropriate engineering, only about 5 kilograms of nearly pure or weapon grade plutonium-239 or about 15 kilograms of uranium-235 is needed to achieve critical mass. So these quantities are very small. So every kg of material has to be accounted for. That is why safeguards are there. So to implement all these issues, Government of India has taken certain international commitments, which has to be honored by anyone who wants to exploit nuclear energy. I'll have a list of those commitments here. In the area of safeguards, we have an agreement between the Government of India and IAEA for the application of safeguards to civilian nuclear facilities. Every IAEA publishes all such material in the form of information circular. In short, they are called INFCIRC. So this agreement is INFCIRC 754, dated 29th May 2009. You can download it from IAEA website. Protocol additional to the agreement between the Government of India and the International Atomic Energy Agency for the application of safeguards to civilian facilities. Now, as I said earlier, under strengthened safeguards, all countries have to sign additional protocol, while non-nuclear weapon states have signed the standard template of additional protocol. For India, it is not the standard template. It is only specific to India, this particular additional protocol. Essentially, this enjoins upon India to inform IAEA about any export of material which are list part 1 of NSG guidelines, which are trigger list guidelines. All the nuclear items which India exports, those are forwarded to IAEA when as and when they are exported. And this job is done by DAE on a regular basis. In the area of security, there is a guideline of IAEA in the form of Information Circular 225. Currently, it is Rev 5, published in 2011, and Convention on Physical Nuclear Material and its 2005 amendment. India has ratified this CPPNM, and India also adheres to nuclear security recommendations here. In the area of safety, there are several guides by IAEA which are definitely very helpful. And there's a convention on nuclear safety, and there are several. And this convention on nuclear safety, India has signed and ratified, and we participate in its deliberation on annual basis when the meetings are held. Then, in the area of civil liability for nuclear damage, there's a convention on supplementary compensation which India has signed and ratified. Now, at the same time, to get waiver from nuclear supplier group in 2008, India gave certain assurances. One was on 5th September 2008, when External Affairs Minister gave a statement on civil nuclear initiative. This statement was sent to IAEA, and it has been published as an information circular and available on IAEA website. I quote the two relevant sentences here. We have in place an effective and comprehensive system of national export controls, which has been constantly updated to meet the highest international standards. This is manifested in the enactment of Weapons of Mass Destruction and their Delivery System Act in 2005. In 2005, this was a requirement that this act has to be there by India before we proceed further, that we will not provide the WMD technologies to other countries. So this particular act was passed by Parliament in 2005. India has taken the necessary steps to secure nuclear material and technology through comprehensive export control legislation and through harmonization and committing to adhere to missile technology control regime and nuclear supplier group guidelines. Here now we are saying we commit to adhere to the guidelines of these things, these control regimes. Then it also says that India will not be a source of proliferation of sensitive technologies, including enrichment and reprocessing transfer. So this is important here. Enrichment and reprocessing technology and also heavy water production technology, they are considered sensitive. We will not export those technologies. This commitment also has been given. Export controls, that was on 5th September, then 8th September 2008, Foreign Secretary wrote to Director General IAEA and enclosed all the documents which are related to export controls. And 8 years later, in May 2016, India has been keen to become a member of NSG. India has already become a member of Missile Technology Control Regime, Australia Group, and 3 different control regime. And the 4th control regime is Nuclear Suppliers Group. With that kind of thinking in mind, in May 2016, permanent mission India in Vienna again sent the document to DGIAA in the area of export controls, acts related to atomic energy, WMD, etc., and said India would like to convey its decision to continue to act in accordance with NSG guidelines. And as per, if you see NSG website, the date of adherence to NSG guidelines by India is 9th May 2016. The date when PMI Vienna wrote to DGIAE, and our application for NSE membership is still pending. China has been blocking it, so it's still India is still of NSE. Accordingly, India has been periodically updating its export controls to ensure that they are harmonious with NSG guidelines, and this is an ongoing process. So, any person engaged in atomic energy must take cognizance of safety, security, safeguards, export controls, civil liability for nuclear damage, and all other issues. And this is now built into the Shanti Act. And this act has placeholders to provide details in rules, regulations, and notifications. Basically, all this history which I have given so far, nuclear energy has been within DAE or companies like NPCIL, ECIL, NFC, AMD. So whatever government wanted by writing letters to them, they were enforcing all the issues related to safety, security, safeguards, civil export controls, etc. But now when outsiders have to come in, they have to be transparently informed about it. That is why a new act was needed, and all these issues are now built into the Shanti Act. So with this, once we have built all these issues in the Shanti Act, what the message which one can give to newcomers? I have been giving this talk outside of DA. Here, all of you are from within the system, you know it. To outside DA, my message which I give is the following. So you recall the incident when a space shuttle in mid 1980s went down. It was due to the fact that a gasket which was not supposed to be used under cryogenic conditions was used at very low temperatures. The result was leakage, and the space shuttle came down. There was a commission established in USA known as Rogers Commission, which investigated this, and Richard Feynman was a member of the commission. In the report, he writes, for a successful technology, reality must take precedence over public relations. For nature cannot be fooled. By nature, you can see it means science cannot be fooled. Scientific laws will remain always there, they are supreme. So, nuclear technology is unforgiving, requires long term commitment, because nobody can fudge with the half life of a radioisotope. That will remain what it is. There is no place for indulging in regulatory tricks. I think many times we read articles in the newspapers that in the industry they resort to regulatory tricks. They go for rent seeking. They go for zero sum games. So those regulatory tricks, if applied to nuclear energy, result will be disastrous. Nuclear power program in India has matured, underpinned by strength in nuclear science and technology, industrial prowess not only of the Department of Atomic Energy, but also the private sector. They are manufacturing all the equipment to the stringent specifications, stringent quality control requirements, which we ask through our tender documents, and responsible conduct of atomic affairs, including export controls, safeguards, safety, security. All newcomers must adhere to responsible conduct. So the message for industry is nuclear industry can thrive only if we imagine, conceive, and pursue it as a well-regulated engineering endeavor. Therefore, they say private sector should unleash animal spirits. This is what you read in papers like Economic Times and so on and so forth. I don't know, we don't need animal spirits, we need engineering spirits for nuclear energy to thrive. So this is the rationale why the Shanti Act, all these terms appear in various ways, and I think I can spend just next 4 to 5 minutes to give a glimpse of Shanti Act, but this is the basis. Basis lies in science. Basis lies in the way controls at the global level have evolved, and it has a long title. Act always has a short title and a long title. This is a long title of the Shanti Act to provide for promotion and development of nuclear energy and ionizing radiation for nuclear power generation, application in healthcare, food, water, agriculture, industry, research, environment, innovation in nuclear science and technology, and for the welfare of the people of India, and for robust regulatory framework for its safe and secure utilization and matters connected therewith and incidental thereto. It has a long preamble that informs about responsible pursuit of nuclear energy by India with an excellent record in nuclear safety and radiation safety. It describes nuclear energy as clean and abundant. This is very important because many times we hear contrarian opinion within the country. It reiterates ongoing pursuit of a closed fuel cycle to enable sustainability of nuclear fuel resources, underlines India's commitment to enhance the share of nuclear energy in the energy mix. That is why 100 gigawatt by 2047 is a target which has been set. It highlights applications of nuclear science and technology in energy, healthcare, food, water, agriculture, research, etc. It notes the desirability to harness the potential of nuclear energy through active involvement of both private and public sectors. So, invitation to private sector, both public and private sectors to own and operate nuclear power plants under a license by DAE and safety authorization by the board. So this license by DAE is necessary. If DAE has to implement safeguard, DAE has to send annual reports to IAEA. DAE should know what is being done. So license by DAE is required for doing. If physical security issues have to be handled by DAE, then DAE needs to know what exactly is being done by the private industry. So a license by DAE and safety authorization by the board. Source material and fissile material remain under the surveillance and control of the central government and prescribed safeguards. Spent fuel to be delivered to the central government. Heavy water used in a nuclear facility is to remain under the supervision of the central government. It permits research, development, and innovation by private sector. Reprocessing and heavy water production to remain under the central government. Enrichment up to a certain threshold may be allowed, but only after a notification has been issued. It doesn't allow at this moment. Tomorrow, if a need arises, notification up to a certain percentage, which will be something like 4 to 5%, can be allowed. It allows private sector participation, but maintains strategic control over sensitive technologies in line with the responsible path India has followed in nuclear affairs. Licensing framework will be prescribed. The central government may grant a license in such a manner and subject to such terms and conditions as may be prescribed, including compliance with financial, technical, management, and other organizational capabilities, covering the aspects of, just note this, design, construction, commissioning, operation, maintenance, life management, decommissioning, quality assurance, radioactive waste management, liability, security, as it may deem necessary for the entire lifetime of the facility or mine. Entire lifetime of the facility is covered. It calls for developing a licensing procedure, and that is a work in progress. Again, there are enough guardrails in the Act. For example, no license may be granted to a company if the central government knows or has reason to believe that it is owned, controlled, or dominated by entities who are inimical to defense and national security or health and safety of the public. A is any company and B is any person. Both are covered here. Section 8 provides for suspension or cancellation, etc., of a license or safety authorization. If somebody is not behaving the way he is supposed to behave, then license can be cancelled. And additional point is that private companies incorporated outside India are not permitted to operate nuclear facilities. This guardrail also is included. Duties and liabilities have been specified in section 10. Every person who has been granted a license or safety authorization under this act shall comply with the terms and conditions of the license and safety authorization and the rules, regulations, orders, regulatory documents issued under this act in respect of safety, security, safeguards, quality assurance and control, radioactive waste management, decommissioning, and maintaining design support throughout the lifetime of the facility or mine. This is important. Design support throughout the lifetime of the facility or mine. All of you know that reactors need refueling. Somewhere we have on-power refueling, somewhere we have refueling every 1.5 years or so. At that time, in-core fuel management calculations are done by reactor physicists. So that kind of support also will be necessary for the private sector to have. Otherwise, they cannot proceed further with this. Maintain sufficient financial security for waste management, decommissioning, settlement of claims, etc. Overall, the Act ensures that the prime responsibility of safety security safeguards lies with the licensee. This is ensured by the Act. There are general powers of the central government with regard to framing of nuclear energy policy, policies for safety, security, safeguards, policy for management of spent fuel and radioactive waste, for quality assurance, establishing, maybe we have to establish many support systems in form of, they could be directorate or wings or divisions, under which we provide services related to environment surveillance, personnel monitoring, dosimetry, and other matters related to radiological protection, and coordinating and supporting government agencies to ensure nuclear and radiological emergency preparedness and response. The Act established the regulator AERB under Section 17. Powers and functions of AERB are defined in Section 24. AERB has been empowered to for inspection and conduct of investigation. It provides for a separate regulator for the strategic sector. We have strategic programs, so for that regulation, again, enough provision has been made. Now, private industry always feel that they want to go and appeal against a decision. Okay, if you want to go for appeal, for that, Atomic Energy Redressal Advisory Committee, AERA Council, has been made. AERA Council consists of 4 persons: Chairman AEC, Chairman AERB, Director BARC, and Chairman Central Electricity Authority. So this is the Atomic Energy Advisory Council. Even if somebody is not still satisfied, he can go to APTEL, Appellate Tribunal. In short, it is known as APTEL. This is a part of the Electricity Act based in New Delhi to hear grievances of people who are not happy with the decisions. It is now provided that 2 experts on nuclear energy will become a member of APTEL so that decision making in this area can be carried forward. If somebody is still not satisfied, then he has to go to Supreme Court, APTEL. So there is a 4-tier adjudication procedures: AERB, AERA Council, APTEL, and Supreme Court. 4 tiers of adjudication is provided for. Even against licensing, somebody wants to go, he also can go through this same tiers. So enough civil liability of Nuclear Damage Act has been merged into it. The basic principles of liability remain the same as earlier. That is, liability is strict, based on the principle of no fault, channeled only to the operator. Liability is limited in amount and time during which the claims have to be filed, and so on. Basically, these principles remain same as in the existing CL&D Act 2010, and amounts have been changed. Liability amounts are in the second schedule, and this is here the second schedule. It's a graded structure depending on the what is the type of facility, size of the facility. Right of recourse is left to the operator and the supplier to negotiate under Section 16. It provides for a review of liability amount having regard to deployment of nuclear installations with advanced technology, enhanced safety features, and other relevant criteria. If tomorrow reactors become safer and safer, then this can be invoked and liability amounts can be tuned depending upon the technology. And liability beyond the second schedule go government. It's not, liability is limited to the operator, but not for the victims of the accident. They have additional provisions. Fuel ownership, if you want to see, there's a Section 3(4)(a), high energy radiation generating equipment. Section 4(2), for example, we have Indus 1, Indus 2 in RRCAT, further high brilliance sources, they also have to be regulated. So that is in section 4.2. How tariff will be calculated, that is also given. Licensing terms and conditions, provision to deny a license, and issues related to occupational safety, health and working conditions, that also is taken care of. In summary, we have a single law that consolidates regulations, enforcement, civil liability, and dispute resolution. In a same one structure, we have everything. Earlier, we had Atomic Energy Act 1962, and we had CLND Act 2010, and there was a talk of another bill, another act like Nuclear Safety Regulatory Authority to take care of regulation. These three different acts were. Third act was never passed by Parliament, but it was drafted and introduced in Parliament. Now we have a single act which combines all the three together. It most importantly, it transparently informs licensee about duties and liabilities. Nuclear energy, there are some liabilities which they have to incur. There are some duties which they have to take care of. So it's very transparent about it. It separates permission to establish a facility from authorization to operate it safely, clear licensing regime and a statutory regulator, central control on core functions, on sensitive technologies. It embeds oversight across the entire life cycle of the nuclear facilities. Thank you.
Can we take some questions?
Yes, please. Yes, please. Question. Welcome. If there's an online question, that also you can read. And
So first we'll take some questions from those who are present in person, and then we go to online also. You have one question?
So basically, after signing this Shanti bill, basically I am from Qatar Incubation Center, and we are asking for collaborative projects. So many queries have come for SMR and those strategic things we are doing. They are saying that Shanti bill is passed. Now we want to venture into these strategic projects. How we can do this activity? Right now, we are saying them that this has not been percolated to us. How to go about it? Let the policy come down into the paper, and we will move further. Is the scenario in due course of time? What should we do, or what will be the procedure for putting private parties into this strategic project which BIRC is doing?
Bill has been passed by Parliament. President has given her assent, and so it's available as a gazette notification. But it has not come into force. After DAE is currently working on rules, regulations, and notifications which have to be issued as a result of passing this bill, passing this act. After those have been drafted and finalized, there will be another notification of Government of India that now this act replaces earlier act of 1962, and this act is enforced. Private industry has to wait till that step has been taken. So I think, and then they have to read it. Not only the act they have to read, they also have to read the rules and regulations and notifications. Then only picture will be clear to them that what is it which is expected from them. But if they are interested in moving in R&D area, that again they have to wait for this to proceed further. Okay? That will take time. Writing of rules and regulations is a very, very comprehensive job. It's not easy job.
Good afternoon, sir. First of all, let me thank you, sir, for such a wonderful presentation, and particularly putting the things in proper historical perspective, how the things are evolved. It was like mesmerizing that going through a history book starting from the 1939 to till date. And as I understand, sir, this act has been passed basically to help in rapid deployment of the nuclear power for the country. And as the target is 100 gigawatt by 2047, my question is, sir, what are our how the private sector can participate? That is one thing. And what are the threats towards this? Because we have set a target of 100. What are the issues where we need to be vigilant so that we are on the course to this target of 100 gigawatt?
Well, I think I will, this is now not written in the act, this is my personal view. So far it was NPCIL and Bhavidi which were engaged in the area of nuclear energy. And all of us have gone through the same culture in this department, and we are aware of all these things, inherently aware. We'll know that this is going to anything damaging, nobody will take that kind of step. But other public sector undertakings can also come in, like NTPC is interested. They are not aware of this. When we go through the corridors of BARC or NPCIL or IGCAR or Bhavdi, all these things we imbibe in the, breathe in the air, that we know this radius, there are half-life cannot be changed. Delayed neutrons will come in 10 to the power minus 14 seconds. And that it has to do a lot with the control system. But is this information known to the top management of other public sector? Answer is no. So that is why it was necessary to bring in all these changes in the act so that other public sectors appreciate what exactly is involved in nuclear energy. So now with the help of this, they will know. And already NTPC is now thinking in terms of, already there is a joint venture between NTPC and NPCIL, and independently also NTPC wants to have they have set a target to, I think, 30 gigawatt of nuclear. So how many private sector people will come in? I think that is what we have to watch. I do not expect currently every private sector person is thinking that SMR or small reactor will be something like plug and play. That's not going to happen. Those kind of SMRs are still to be developed, where it will be plug and play kind of system. Every reactor will need refueling, every reactor will need in-core management, every reactor will need maintenance. So once they know all these issues, again, I will tell you one example. I was talking to a group of private sector people and telling them nuclear reactors can operate for 1,000 days continuously. That's the kind of record we have. They were very happy, because there's a flip side to this. And flip side is, if a reactor is operating for 1,000 days, that means operators do not know how to start the reactor, accidents don't happen. They don't know how to manage the accident. So there has to be a full scope training simulator. They immediately receive the shock of the life. Oh, that means we have to invest in a simulator also. It has to be there. NPCIL has simulators at all sites. So this kind of issues will be now known to. इसको भी रहने दो इधर. Question कोई आ गया तो
Okay.
So this kind of issues, they will know it. So I do not expect a flood of private sector. 1, 2, 3, that's all. Not more than that. What are the threats? Threats is availability of uranium from international market. How much uranium is available? What if we see past history? What has happened is, as the uranium demand increases, exploration is intensified, more mines are open. So far signal after Fukushima was uranium will not expand. Now present signal which mining industry has received is that more uranium is needed. So exploration will be intensified, more mines will be open. Perhaps that situation will not arise, but this is something which we have to wait and watch. That's a major threat which can be there.
Thank you, sir. This brings me to one more question, sir, if you allow me one supplementary question. You have highlighted, sir, 3S, which are very important: safety, security, safeguards. And now my second question is, you know that already the outside industry doesn't know. That is the reality. They don't know that what nuclear is. Okay. Now the second question is, what role HBNI can play in strengthening that okay, we can make them aware of, or how we can seize this opportunity for the growth of HBNI as well as the nuclear power in the private sector? I know, Jain sir, you are have been associated with HPNI, and now also you are there.
Yeah,
How we can do? What are the
there are certain expectations from HBNI as far as private sector is concerned, that HBNI or DAE as a whole, let me put it this way, that we'll be able to train more people for private sector. But in concrete terms, how it evolves, that I think is still at a thinking level. So I think we'll have to wait for that for some more time. And as the picture evolves, you will know it.
I mean, some discussions at very top level have been just initiated.
So I think it's not better we don't speak about those things at this stage. Let them come to a concrete stage, then only we'll talk about that. Okay?
Thank you, sir.
Yeah.
Sir, you just talked of the complexities that are associated, and you say private sector also has started realizing it. Now, other than licensing and controlling the strategic part, is there any plan where DAE can handhold them during installation and running, or is there any such provision which will ease out and also probably tackle their anxiety of entering into this particular venture?
Now I think here there is a issue of perception. NPCIL issued a request for proposals that okay, any private industry which is interested in having a 220 megawatt nuclear reactor as a captive power plant, they can set it up and hand it over to NPCIL to operate it. To that request for proposals, there were many queries were coming, but somehow they were very uncomfortable with regard to the control being remaining with NPCIL. So perception here is that if the control is with the government, things will not move. So while in my view that was a very good proposal, they use the project management procedure of the private sector where decision making is faster to set up a reactor and hand it over to NPCIL for operation. For them, there is no responsibility. NPCIL was taking all responsibility. But some that went on into dialogue mode, and before final decision could be taken, this bill has come. Now they are saying that we will like to own a reactor, own and operate a reactor. So as I'm talking to private industry, I will tell you one incident. Somebody came to my residence and was saying that I asked him a question: if ARB tells you to shut down the reactor because of some safety violation, what will you do? He said, I'll go to court. That was alarming. That reply was, I found alarming. If you go to court and in the meanwhile something happens, then who will take care of safety? So they still think that they can go to court and get a stay order. Court cannot stay radioactive decay. That will continue. Court cannot prevent a decay from coming out of a reactor even after the reactor is shut down. So that realization is still not there. So it will take time for that realization to sink in, and then only, that's why I'm saying I'm not hopeful a flood of private companies coming in. It will be only larger companies who have very deep pockets, are willing to invest and wait. So when you tell them that once you start investing, it may take 7 to 8 years before electricity flows out and you start getting something, they go back. They are not interested in waiting for that 7 to 8 years. And if we see data with regard to how much private sectors is investing into R&D, that data doesn't give you confidence.
Because that was also my concern, sir. The point that you raised, that it will start generating power only after 7-8 years.
Yes.
Now, into this, I count that after when you start decommissioning, then also there are quite a few number of years when it is not productive economically.
Yes.
So all those things for a private investor, would it be lucrative?
if they, after all, NPCIL is a profit-making company. There are many profit-making companies around the globe, but your apprehension is genuine. Nuclear energy is thriving. Say in France, EDF is owned by French government 100%. In China, there are two companies both owned by Chinese government. In Russia, where it is owned by, again, the government there. Other places, they are struggling, regulations and re-regulations and all that is going on. So what happens in India, we'll have to wait and watch. But large number of companies coming, my expectation is no.
Thank you, sir.
Sir, thanks for this wonderful, talk. Sir, my question is that you said that the private sector which is coming in has to be Indian, right? It has to be an
Yes.
Indian. So, regarding manpower, what if they are hiring people from outside? Is that allowed, or is that being considered in the act?
Yes, in the Companies Act, there is a terminology called key management positions. In key management positions, it may not be possible to have foreigners. Key management positions have to be held by Indians.
Okay, so that means now if we look into that entire timeline of 7, 8, 9 years, so we still have around at least a decade to train our manpower.
Yes, we have time.
Right.
Yeah.
So I think, sir, HBNI, HRDD, BRC can really
Yes,
put in
yes.
some thought into that and train our manpower accordingly.
Yes.
I mean, obviously, it's going to generate so much amount of employment to people, right?
Well, I think those things, it will be premature for me to talk about those things.
Thank you, sir.
Okay, yes.
So first of all, wonderful presentation, sir. I would compliment you.
Thank you.
It is a query only, because I could see that there is a lot of going on in newspaper as well as in port, that government has reduced the liability damage. Is it true, or what exactly do you think?
I think the way it is being presented, it's a half truth. Why I say half truth? Yes, liability of operators as they are specified in the table which I presented, they are different from what they were earlier. But the compensation which can be given to a victim, that has not been changed.
Okay, it is the
So
same.
that part they are trying to fudge in their whatever is coming in the newspaper. Liability of operator has been now graded liability depending on the thermal power of the reactor. That table has been introduced. Second thing, there's a change which has come is that earlier it was provided that there was what is known as Article 17B of Civil Liability for Nuclear Damage Act, that operator can have a right of recourse against the supplier, that he can take supplier to court and tell them that no, it has happened because of your mistake, and so you have to pay part of the compensation. That part has been deleted. It has been left to operator and the supplier to negotiate in the contract. It has not been totally deleted. It has been, operator can still negotiate with the supplier and have that. So what private sector wants, that they should have full liberty, so that has been given to them.
Thank you, sir.
Okay.
Sir, there are two questions on online participants.
Yes, please read them out. Yeah.
Sir, the first question is there any integration of environmental laws in Shanti Bill?
With regard to radiation, yes, those things are there. But other environmental laws, they have not been touched. They remain as they are.
Then second question is from Madam Uma Shankari Kannan, our own colleague from BRC. In this scenario, how much of manpower will be required for this massive mandate?
As I said, I am personally not expecting a flood of private sector coming in. Public sector like NTPC or maybe one or two more companies will come on. So we will need manpower, but that is something which we can manage. After all, in training school that we have people who manage training school right here, how many applications we get every year, and how many we select much, very small fraction of that. So people are available, we have to train them. They maybe it will require a little more effort to train them, but enough engineers and scientists are graduating from our universities. We can provide training to them. Rather, in this case, NTPC has taken a very, I should say, innovative decision. They advertise in the newspapers in Delhi that all retired employees who are of DAE who are staying there in the national capital region and willing to take lectures in the training schools they are established in Noida, they can apply.
Oh, very good.
I do not know how many applied against that advertisement. This is open advertisement in the newspapers. This came in, I was told by people in Delhi that in all newspapers this ad was there.
Then, sir, further one question adding to this, again from Madam Mazankari only. Also, probably she wants to know that because given that the fuel required, that will be high, are we geared up for this? Again, relating to fuel requirements, sir, how we are going to meet that?
Well, fuel requirement, depending on now, once we come to know the complete program, nuclear fuel complex is manufacturing fuel for PSWRs. And they have established a greenfield project. Apart from expanding their output in Hyderabad complex, they have set up a greenfield plant in Kota, which I think is about to be commissioned soon. So capacity will change. So one has to set up more and more greenfield projects here. But in the Shanti Act, as far as the fuel manufacture is concerned, private sector can also do it. This is provision has been made for that.
Okay. One more question, sir. How will this bill act help entrepreneurs if someone wants to do startup? Probably from some student.
A startup can be done. We have said that R&D and innovation is left to private sector. But here, as I said, as far as the established industries are concerned, there is a record of they are not investing much in R&D. This we have talked several times. And the latest data which I have, the major investment by private sector is in R&D in automobile. Tata Motors spends about 22,000, 23,000 per annum. The next company after Tata Motors is Reliance, which spends 3,000. So these amounts are abysmal. They have to increase many times more before we can, private sector can really do R&D.
Thank you, sir. These are a few questions.
Any online? So one more.
Thank you, sir. Sir, as we were talking about like privatization of this nuclear industry, one thing which comes into my mind is like, as privatization will start, the game will change in terms of innovation. When innovation is happening more, people will tend to save more money by utilizing fuel efficiently. And in that process, there will be innovations in such a manner that the specific private player would like to keep it secret for themselves only. They won't like to share it with everyone, so that they are having advantage over economics. In this bill, as you explained, there was no component on IPR, intellectual property right. So what is your take?
No, IPR is allowed. Patenting in this nuclear sector is allowed now. This is very much embedded in the bill.
Okay.
That is taken care of.
Unlike recently.
That's allowed. But I didn't talk about that. I was not expecting that also will become important. But it is allowed. Okay.
Good afternoon, sir, and thank you for a wonderful talk. My question is somewhat related to what he asked. So I wanted to know the rights for research and innovation given to private sector are limited, or they are also under some,
enough is provided here.
Enough is provided.
Okay. Yes, Ramya.
Hello, sir. So once again, thank you for this wonderful presentation which you did for the act. It was very detailed and with a historical background. I just wanted to ask a question related to the opportunities for R&D for the private sector. Do you see this act as something which can give or add momentum to our progress in the direction of the 3-stage nuclear program? Do you think that can ultimately help us reach the goal of the 3rd stage much earlier?
Apart from older IITs and a couple of other institutions which are there in the country, others institutions have a long way to go before they start doing this kind of R&D. Yes, something positive will definitely emerge, but to what extent, that we have to wait and see. I see a very slow progress in that direction, but not a very fast progress. But yes, there will be slow progress.
Okay, something
Positive. But progress in this is my now personal opinion, will be very slow. Because as I said that investment in by private sectors in R&D is something which needs a lot of improvement in our country. I think you have worked in the office of PSA. You know that a report which was commissioned by PSA regarding R&D and which came in 2024. I have that data in front of me. Tata Motors 20,000 in 22-23 and Reliance Industry 3,001 crores. This is the kind of that report is something which tells you a lot. At the same time, we have to be very hopeful. Things are moving in the right direction, and the current evolution in geopolitical situation is going to motivate Indians to stay in the country, and that will be helpful.
Right. So basically, the act doesn't give much provisions for enhancing partnership in R&D. And if suppose somebody is interested, they'll have to probably pursue through ANRF, other avenues like Anusandhan National Research Foundation.
So Act provides for all this.
Mm-hmm.
Now, Act cannot say that how to cooperate in R&D with others. That has to come from Anusandhan Foundation and other. Act is now have opened up all the possibilities.
Okay, that's great.
Now, once possibilities being open, they can already, for example, IIT Madras is already thinking in terms of micro reactors. And I think it's only a few days back I had a telephonic discussion with some of the people. They are our own, Dr. Kalol Rai is heading in. And again, I was discussing economics. They have not given a thought to that. Economics of microreactors is very complex. It's too expensive for us to venture into microreactors. Similarly, I think IIT Bombay is also thinking as to how they can move about it. They have invited me. I think next week I'm going to IIT Bombay, and a month later they have a big conference in this area. They have set up a India Nuclear Energy Forum. Again, so people are just now looking at it, thinking about it, but one cannot expect a step change. It will be a slow evolution as we proceed further. Step change can lead to instabilities. That should not happen. That will not happen.
Thank you, sir.
Yes. Yeah.
Thank you, sir, for the nice talk. I want to know that since we will be requiring more and more manpower in the field of nuclear science and technology, will there be any responsibilities given to the educational institution, also all the institution across India, to train manpower or have it in their curriculum? Because right now we don't have
yes.
many institutes.
So we cannot give responsibilities to institutions. If they come up, we can help them. This is all I can say, that if any institution is coming forward, we can help them. I think in this regard, my thoughts go back to 2011 or 12, sometime at that time, maybe to early 2011. there are 5 or 6 institutions in the country who wanted to start nuclear power
science and
program.
engineering.
And I was at that time director of knowledge management group. A letter came to me, and letters were coming to me. All these letters, whosoever are getting, they are sending it to me. I responded to them that we can reserve one seat for you to each of these 5 institutions. One seat for you in our training school next batch. Who can become your faculty later on? Please send. Nobody was willing to send a person for 1 year. They were looking for that we should go and teach there. That is not possible. So here we have to be very careful. The way private universities are running in this country, we should ensure that they do not squeeze us out. But if they want faculty to be trained, yes, we can train their faculty, but we cannot provide faculty to them year after year. This part has to be balanced together. And I recall when that letter went to those 5 institutions, even replies didn't come. They were all private institutions. State governments don't have any money. Now, when it comes to central universities and IITs, something may happen there.
Thank you, sir.
Yes.
My question is about liability. Liability means it is still about the government liabilities, or if something is happening, when operator is pursuing the reactor operation and something happens, goes wrong, then who is the liable, and what are the sufferers, how they will compensate it by this act? What is the provisions for that?
There are detailed provisions in the act. They are there in the current act also, and they have been translated into this act as well. Whenever any accident happens, liability is passed on to the operator. It's a strict liability. That means it cannot be challenged. Operator is strictly liable on the principle of no fault. No victim has to prove that there is a fault on the part of operator. Yes, operator will take liability. And for that, there is a provision that there will be a claims commissioner, which is built into the act. Claims commissioner will start getting those applications and start providing compensation to victims. If the liability accident is very huge, then there will be a nuclear damage claims commission, so that there are several members there to share the workload, and they will start doling out compensation to victims depending upon the formula which will be evolved. And but the liability of operator has been capped at a certain amount, but the amount which can be given to the victim, that has not been capped. The balance will be provided by the government. Yes, sir.
We are in 2026, that is 21 years to 2047, at 8 gigawatts currently. So the target of 100 gigawatts is like 12-fold higher. And with your inputs regarding limited participation that you anticipate from the private players, do we foresee that NPCIL will have a larger role to play still, or those 2-3 players will still take the larger chunk?
NPCIL has come up with a plan of establishing 55 gigawatt out of this 100 gigawatt. NTPC has said they will take up 30 gigawatt. That makes 85. Remaining 15 we have to wait and watch.
Okay, sir, thank you.
And there is a vision document which is available on DAE website. It is known as 2047 vision, or what is that document?
The work was done 2 years back.
There is a document. You can read those 3 volumes.
3 volumes.
You have those 3 volumes. That there, and NPCIL says they will do 55 gigawatt. I think this is why I'm telling from memory. So a lot is already covered. 55 gigawatt plus 30 plus, I think at least the remaining 15 people should be able to do.
So now India is now having very ambitious plan. From here's the question. And likewise, US also is giving a rethink. They also want to now revive their nuclear program, and so are the other countries. So uranium short supply, even if we add forecast of more and more exploration, because uranium abundance itself is 3 ppm, and most of it is deep buried. We explore only surface and subsurface. So this supply demand gap definitely is going to be an issue. If other 10 countries think in terms of 100 gigawatt, 200 gigawatt, and so on.
That means that those sources which we are currently considering as uneconomical, they will have to be exploited as the prices go up. You see, in India, we are already exploiting sources which are poor, very lean sources. And once we have opened mines in Kadapa region of Andhra Pradesh, where the source is very lean, we had to develop processes based on alkaline leaching, which earlier we were not doing in Jaduguda. But we are doing that because otherwise we don't have sources. So those kind of sources all will have to be exploited so that we can meet the requirement. But yes, this issue will come up, and all lean resources will have to be exploited.
Is there any possibility in risk? Is there a possibility in risk in this fuel sector in this Shanti bill?
Risk? No,
Yeah.
I
In this fuel that goes to
Congress.
no. You see, issues with regard to diversion, they happen when you allow bulk handling of materials. When you provide fuel to private sector and they return the fuel, that's only number counting. But in reprocessing, there is bulk handling of material that remains with the government. So there are certain subtleties which have been already taken care of in this area. So in number counting, what can go wrong? You will always take care of that.
Bundle in, bundle out.
So in reactors, those possibilities are not there. In bulk handling, those possibilities are there, and there we have kept our government's control.
Salvage stuff here.
Yes.
Sir, thank you very much for your enlightening and thought-provoking lecture. Now is the time for a vote of thanks to be proposed by myself only. Respected Sir?
We will do.
Okay. May I request Professor Tyagi sir to kindly present a memento to Professor R.B. Grover as a token of our respect.
I feel honored to hand over on behalf of HBNI a very small token of appreciation for your vast contribution. Thank you. Oh, it's a green environment.
Thank you, sir. Respected Professor Grover sir, Member Atomic Energy Commission and Chairman BRNS Board, Distinguished Professor Emeritus of HBNI, Respected Professor A.K. Tyagi, Dean HBNI, all the Associate and Assistant Deans, distinguished faculty members, scientists and students. On behalf of HBNI, I extend my sincere thanks to Professor R.B. Grover sir for delivering an insightful lecture today. His address has greatly enriched our understanding on this important subject. I also thank Professor A.K. Tyagi for the welcome address and Professor Madhumita Goswami for introducing the distinguished speaker. I would like to acknowledge the faculty members, scientists, students of HBNI, CIs and OCCs for their enthusiastic participation, which makes such academic interaction meaningful and enriching. I would also like to thank our organizing team, supporting staff who work behind the scenes to ensure the smooth conduct of today's program. With these words, I once again thank our distinguished speaker and all the participants for making this program a success. Thank you very much.
Excuse me, Meenakshi, for group photo. Please come.
इधर बाकी लोग